Okay, let's do some videos on 11.4b. I'm going to be talking about the limit comparison test. Last time we talked about the comparison test. This is a little bit different. Okay, so let's look at, suppose you have a series n equals 1 to infinity of 1 over n plus 1. Okay, now you look at that, and if you can make a guess, you're going to think this guy's probably going to blow up because it looks a lot like the summation 1 over n equals 1 to infinity. But with the limit comparison test, if you want to show something blows up, you got to make the one that blows up be the smaller one to push this into infinity. But how do we compare these two guys? Which one's bigger? Okay, here I added something to the bottom, made the bottom bigger, which makes this guy smaller. So I got this. But if I show the sum of this sequence blows up, that doesn't push this into infinity. So the comparison test doesn't work well on this one. Now, if it was a minus, then everything would be okay because I would have that and show that the sum of this blows up would mean the sum of that guy blows up. But I don't have that. I got a plus. Now, there's another test called the limit comparison test. Read your book, which says if you got two positive sequences, an, bn, and if the limit of an over bn, or you could put bn over n, doesn't matter, if that goes to some number c that's bigger than 0, then both summation of an and summation of bn do the same thing. So if this one blows up, then that one blows up. Or if that one blows up and this one blows up. If this converges, that one converges. If that one converges, this one converges. So let's do it on this set here. We think this guy blows up. Let's prove it doing the limit comparison test. Okay. So first thing, you're given this. What are you going to compare it to? It's just like we did last time with the comparison test. Pick something that you think is going to work. I think that looks like 1 over n. I just added 1 to it. So I think it's going to blow up. So I'm going to compare it to 1 over n equals 1 to infinity. Okay. Now, these are the series. Let's look at the limit as n goes to infinity of the division of the sequences, the inside parts. So whichever way you want to do it, it doesn't matter. 1 over n plus 1 over 1 over n. Okay, what's that going to give you? That's going to give you the limit. N goes to infinity. Flip this and you get n over n plus 1. It's four-story fraction. I flipped it and multiplied. And now when you do that, as n goes to infinity, if you want to be technical, you could multiply top and bottom by 1 over n. And so that's going to equal the limit. N goes to infinity of, that's going to be 1. That's going to be a 1. And that's going to be a plus 1 over n. Now as n goes to infinity, that's going to 0. You're going to have 1 over 1, so this equals 1, which is bigger than 0. So that says that these two series, so since the sequence of dividing the limit as dividing the two sequences went to a number, that says that the series, when you add them up, act the same way. So whatever this one does, this one has to do the same thing. Now I do know something about this guy. That guy's going to blow up, therefore this guy's going to blow up. So by the limit comparison test, the summation n equals 1 to infinity of 1 over n plus 1 diverges to infinity. Okay, now if I'd have compared it, if I thought it would have converged, I would have picked something that looked similar to it that I thought converged. Do this and hopefully it goes to a nice number that's bigger than 0, and if it does, then they both do the same thing. Okay, that's the limit comparison test. Stop this video and do some more here in a little bit.